You got math students. This is video notes 4 through 6 for basic algebra review. So if you don't have your packet, go grab your packet. Hit pause and go grab that. Otherwise, if you have it, return to this page. Starts objectives 4 and goes through 6. It's all about like terms. Should be a little quicker video than some of ours in the past. First thing we're going to do is just start with some notes on the side here. Not very many, but and talk about what like terms are. So in algebra, like terms are terms that have the same variables and powers. Okay, so some examples. If we have 4x squared y and negative 2x squared y. Okay, the number in front or the coefficient, those do not have to be the same. So 4 and negative 2 don't have to be the same. But the variables used and the powers on each of those variables need to be the same. So we have an x squared, y, and y. So yes, these are like terms. Okay, if we have, very similar here, 4xy squared and 4x squared y, they look very similar. Again, the number in front doesn't matter even though they're the same. This has just an x, that has an x squared. Those are not, it's the same variable, but not the same power on the variable. Same with the y. This is y squared, this is just y. These are not like terms. Okay, a few more examples. Negative 6x squared, y to the third z, and x squared, y to the third z. This has a negative 6 in front, this has nothing in front, but that's okay. X squared, y to the third, z, those are all the same. So yes, those are like terms. Negative 6x squared and negative 6y squared. Number in front's the same, but that doesn't even matter. The power is the same, a squared, but this is an x, this is a y, so that's no. And the last one, 2/3 and negative 4. Neither one have any variables or powers. This is a fraction, this is a negative number. With all that being said, these are like terms. The number itself doesn't matter. No variables and no powers means these are constants because they have no variables. Constants are like terms. Okay. So that's just kind of the only notes that we have. Now we'll just do some examples. We're going to kind of go out of order again because I'm going to do all the one type first, and then we'll go back and do the other objectives after. So the first problems we're going to be looking at are just identifying like terms. So number 34 here is one. It says, which of the following is a like term to 6t u to the third? So the number in front doesn't matter at all. We just need to find one that has t and u to the third. T u to the third. So this should be our answer, but just look at the other ones. Well, that's u to the fourth. There's no power on the u here. And this has t squared, which this is not. So our answer for that is just A. I'm going to turn the page, go to 41. It says, which of the following algebraic expressions has no like terms? Okay, I'm just going to start at the bottom here. This one might look like it. You have an x but this has -6 has no variable. 1/6 has no variable. So these are actually like terms, and we are looking, now you got to be careful with the directions here. We are looking for the one with no like terms. So this is not our answer, because they do have a like term. Here, -6x and 4x, they each have an x with no power. Those are like terms. So that's not our answer, because we want the one with no like terms. -9y, 7y, those are like terms. So this should be our answer. We have a -6x. This has a y, and this has nothing. None of those are like terms, and that's what we are looking for. No like terms, so that is our answer. Okay. I'm going to turn the page a few times again to find the next example, and we'll be heading back for different examples. We're going all the way to 57 to find this type of problem. Okay. So they're going to give you a list of terms, which are just parts of an expression. We have to find which of these are like terms. So we got to group them up. Okay. So we got a 4x to the third. So I'm going to look for anything else with just an x to the third. Not that. That is a like term. Okay. And that's it. So I'm just going to do something. I'll put a box around that. So those are like terms. Here we got a 3x. Here we got a -6x. They both have x with no exponent. Those are like terms, so I'm going to circle those. And then x squared and -2x squared. If there's no number in front, that doesn't matter. And they each have an x with a squared on it. So those are like terms. So I'll just do a different shape around that. Triangles on those. Okay, so we got to group these up. There are actually 3 sets of like terms. 4x squared, or 4x to the third, -8x to the third, right here. We have the circled ones, 3x and -6x, 3x, -6x. Then we have x squared and -2x squared. Those are right there. This is our set. Now, in a problem like this, it's possible they could give you this many, but only two. There's only 2 pairs. See, the pairs are separated by these semicolons. So, or they could have 1, or they might give you no set of like terms. Okay. Turn the page one more time, one more type of problem like this, and we'll go back and do the other ones. Oh, just to give you an example of what I was just talking about. Same type of problem we just did. We have an 8, so that has no x on it. So that had, whoops, sorry about that. Let's erase that. So the 8, there's no other just constant term, so there's no like term for that. -2x squared, there's nothing else here with a x squared. 4x, that's just an x. There's nothing else that matches it. So this problem actually has no like terms. Okay. All right, we're going to flip all the way back to the first page of this section and find number 37. Okay, so now we're going to be looking at the second objective here, and it's combining like terms. So combining like terms means you find like terms and just add them together. Okay, so number 37, we have a 9x, and we just got to look, is there any like terms for that? So 9x, this has a y, and a -2x. Those are like terms. So 9, you can either say -2 or plus -2. So far we have 7x. Then we have a 3y. Now make sure you notice there's a negative in front of it. So let's look and see if there's any other y's over here, plus 6y. So we have -3y plus 6y. If you needed to use your calculator for that, you could. Okay, -3 plus 6, or just think, I have 3 negatives, 6 positives. I have 3 more positives, so that's plus 3y. And if you have adding positive and negative numbers is tough for you, you can either use your calculator or ask me a question. I can help you with that. So here is what you get when you combine like terms. Okay. Going to stay on the same page. We're going to do the next problem, number 38 here. We have a 3x and a 5x. Those are like terms. So put those together to get 8x. We have a 6 and a minus 4. Those are like terms because they have no variable on them. So those are like terms. 6 minus 4 gives you a plus 2. There's 8x plus 2. Okay. Go skip one page, go to number 44. It's basically the same type of problem, but they just say it different. They write it out as a sentence, which is a simplified expression for x squared minus 2x squared plus 9x squared. So first thing to notice is that has an x squared, that has an x squared, that has an x squared. They're all like terms. Okay, so you can do this a lot. Some of you might be able to just do it all at once. I'm going to go just kind of in order here. If there's no number in front, that's like saying a 1. So here we'd have 1x squared minus 2x squared. That gives us either a negative x squared or a negative 1x squared. I still have this plus 9x squared. So negative 1x squared plus 9x squared will give you 8x squared. Okay. All right. So now let's go to the last type. We're going to go all the way back to 35 again. It's going to be the same thing, but adding a step in there. Okay. Or basically it's with parentheses. Now, sometimes parentheses means you have to do something, sometimes it doesn't. In this problem, since there's a plus in between the parentheses, this is no different than just saying this. It's the same with or without the parentheses. Now, where this is going to change is if there's numbers in front of the parentheses or this is a minus, and we'll talk about that. But this problem is exactly the same as this. So now we just look for our like terms. 8x, 5x. Those are 13, that's 13x. Then we look at a minus 3y and a minus 4y. So you have 3 negatives, 4 negatives, that's 7 negatives. So minus 7y. The answer is C. Okay. 36. So this is what I was talking about. Now we have numbers in front of the parentheses. This makes it different. Okay, we can't just say, oh, 4x and 3x and then 1 and 1. It's 2. It doesn't work that way. We have to do distributive property first. When there's a number right next to parentheses, we have to do this stuff. So 4 times x is 4x. Then we take the number outside times an x. So that's plus 4. This is, now we go here, and it's plus 3 times x, so that's plus 3x. Then it's a plus 3 times a plus 1, and we get plus 3. So again, because that 3 is right next to the parentheses, that's when we do this distributive property. Now we can add like terms. 4x, 3x, that's 7x, 4, and the 3, those are no variables, so we can add those together, and that's plus 7. So 7x plus 7. All right, 4 problems left. Top of the next page. Okay. Now, you have to be careful on this one. You do not need the distributive property here. So what I mean is, sometimes people see a parentheses and they see a number and they think they got to do this. Don't draw this. I'm going to erase this. And they think they got to do that. Not on this problem. Because the number is not right next to the parentheses. There is a plus there. Okay? So really, these parentheses don't mean anything in this problem when there's a plus there. So that and this are the same. Okay. So since the number, if the number was right next to it, then we'd have to do that. But now we look at this. 4 has a like term with 2. So 4 plus 2 is 6. This has no like term, so we just leave it. Now the way I wrote this is 6 plus 7x. I don't see that here. Well, when you're adding, the order doesn't matter. So we can switch the order when we're adding. And there's our answer. Okay. I'm going to go right to number 40 here. There's a lot going on. Now we got more going on in 40. Okay. We have this 5. That's by its own. We have a 2, a minus 2, but the 2 is right next to the parentheses. So that means we have to do some stuff. The plus 3x is away from the parentheses, so we don't have to do the arrows there. So what this will end up being, the 5, and we have a minus, well, actually, I won't even do that yet before I write that down. We have a 5, and then we have a minus 2. Because the 2 is next to the parentheses, we have a minus 2 times a negative 4. So this is like a negative 2, negative and negative gives you a plus 8. Okay. Now we still have to do the second one. We have the minus 2 times a plus x. Okay, so there's two ways you can write this here. You can write plus and negative 2x, or you can just write minus 2x. But the thing you need to know is minus and a plus, that's going to be a minus or a negative. Okay, and then like I said, this is not right next to the parentheses. So we just add that on the end. Okay, now we take a look at the like terms. No x's, no x's, so we add those together. There's an x and an x, so negative 2 and a plus 3. So there's one more positive than there's negative. So we could say plus 1x or just plus x. Again, this exact answer isn't over here, but x plus 13 is the same as 13 plus x. Okay. All right, 2 problems left. We're going to turn and find number 52. Okay, a very similar example of what we just did, but I want to go over another one of these. These would be the hardest type that you'd find. So again, this is by itself, a number next to parentheses. So we have to do this stuff. And then again, a number next to the parentheses. So we have to do this stuff. Okay, so the 6x is all by itself. And we have a minus 2 times an x. So that gives you minus 2x. Then we have a minus 2 times a minus 4. Minus minus gives you positive. 2 times 4 is 8. Okay. Now we continue. Same thing here. These are next to each other. So we have to go 6 times just x. Both positive, so it's plus 6x. And then a plus 6 times a minus 4. So positive and a negative gives you negative. 6 times 4 is 24. Okay, so now let's look at like terms. We have a 6x, a 2x, or minus 2x, and a positive 6x. Okay, so 6 minus 2 is 4, plus 6, we get a total of 10x. And then the other like terms, we have just a plus 8 and a minus 24. Okay, there's no variables on those. Those are like terms. Gives you minus 16. There's our answer. Okay. Again, remember, any of these aren't making sense. You can hit pause. You can rewind, watch it again. Okay. Otherwise, when we're done, ask me a question. Last one, 56. Okay. This one can be a little tricky one. We have a number next to parentheses. Okay, so we know we're going to do this. Okay. Then here you might look at and say, okay, there's no number, so this just is the same. But if this was a plus, yeah, you just use these numbers and you're fine. When there's a minus in here, you're still taking that minus to both of these because it's in parentheses. So some people think it's like having a -1 here and doing that, or you can just think of if there's a minus in front, you have to apply that negative to both of these. So let's do the easier part first. 5 times x, which is 5x. And 5 times a -1 gives you -5. Then we have a minus an x. So that's a positive x with a minus in front of it. So we're just doing that, just a minus x. Now here's the part that some people might make a mistake on. They might forget about this and they just write -1. But we have a minus this whole parentheses, so we have to minus a -1. Minus a -1 changes to plus a positive, because a negative and negative make a positive. Okay, so now we look at the like term. Now if if that didn't make sense, rewind it, watch it again afterwards. If it still doesn't, that's when you ask me a question. So we have our like terms, 5x and a minus x. So 5 positive, 1 negative gives you 4x. And we have a -5 and a +1. Okay, so it's just kind of the other way around. We have 5 negatives, 1 positive. It gives you -4. And there's your answer. Okay. All right, so now go over the last page where the answers are and just circle what problems we did. And again, I'll explain how to use this to help you. So we did 34, 41, 57. We did 64, 37, 38, 44. A bunch of them down here. Did 35, 36, 39, 40, 52, and 56. So again, the way you use this page, first of all, is just, let's say you were doing number 59. First thing to do is just see if you got it right. Okay, if you're going to practice, now remember, you don't have to do the other problems, but to make sure you're ready for a test, you might want to try some of the other ones. So if you're doing 59, you get C, great. If you did 59 and you didn't get C, but you look at it and you think, oh yeah, I know how they got C, good. If you did 59 and you didn't get C and you don't know why they got C, well, that's why we did this group of problems are all kind of similar problems. So if you don't know how to do 59, it's going to be just like one of these ones that are circled. So you look back, see which one it looks like, and see if you can figure it out. And then if that doesn't help, ask me a question. Okay, write in a message. Say, I don't know how to do 59, and I'll either meet with you right then, or I can make a video showing you how to do it, or something like that. We'll get it figured out. Okay. So again, copy these problems in your notes, send me the pics, and then you get the points. And then practice some, see when you're ready for the test, and ask me for the test.